So we are going to use Matlab to graph a plane that contains this line here and is perpendicular to the plane z equals 3x plus y plus 3. Now we are working with live script, so we will ask it for a new live script. See, I clicked it there and it brought it on another monitor for me, and I brought it here. So first what I will do is that I'll just go ahead and draw these two. Okay, so we have symbolic variables, and I am doing this just to avoid typing mistakes. I'm just copying and pasting here. So I created symbolic variables x, y, z, and t here because this is what we are going to use. And then I'm going to plot a line in 3 dimensions. So I will do f plot 3, that will give me line in 3 dimensions, and then I'm going to specify the line width. Okay, so line width equals, let's take 3 generally is what I like. Okay, but you can have your own, or just say color here. Color equals, let's keep the color black, and for black actually B will give you blue. Okay, so for black it is this quotes case. So I will do control enter, remember. So in order to get a plot of the line, and it will give us a plot of the line, and it's right here. And then I'm going to say hold on. The reason for that is that we want everything to be in the same window, and we shall also make the axes equal. So let's just write that first, that we want our axes equal and make them of the same length. So I would just in this case we have very straightforward situation, so we will keep them just from -10 to 10. Later on you shall see that we may have to get different lengths of axes. So here we go. So we got everything. Now here the plane is a surface, so here we are going to plot it as a function of x and y. So for that you may use f surf and then 3 times x, and remember for the product sign you have to get this star, otherwise it will not talk to us. So once we do this, and since the line is black, we may change a different face color. So let's go for, say, face color, and here we have to do, we got face color, and let's take, say, face color blue. All right. Okay, so here the face color is blue, so it will graph okay, so here we go, we got this thing here. Let me have it rotate. I'm sorry, my computer is slow. Okay, here. So what we want now is that we want a plane that contains the line and is perpendicular to this blue plane. So for the line, what we can notice is this, that this line is parallel to, look at these 3, the vector 5, 4, 5, right? And it passes through the point, if you take t equals 0, 1, 1, 1. Okay. So here is what we have, and it's parallel to this. And the plane that we have, if you rewrite this equation, it is 3x plus y minus z plus 3 equals 0. So the plane is perpendicular to this vector 3, 1, -1. So what will happen then? If I took cross product of these two vectors, then that vector will be perpendicular to the line as well as perpendicular to this plane. Okay, and then consequently if we let that plane contain this point 1, 1, 1, then it will contain the entire line, because we have the cross product of these two having a vector perpendicular to that plane. Now in general, I would say we are beginning, so do cross product by hand, but since we are using this thing here, we will just go ahead, and this is how we will type the vectors. So let's just type the vectors here, 5, 4, 5, which is the vector right here, and then we will say cross. Okay. Oh no, just a second, I have to say comma. Okay. Then 3, 1, negative 1. Okay. So if I say control enter, it should give us the cross product. So that's negative 9, 20, negative 7. So what the equation will be of the plane, you can see the plane is what? The plane is perpendicular to this vector and contains this point. So that will be, the plane simply will be, let me just go ahead and type it now. So the plane will be negative 9 times how much? X minus 1. And here is just a coincidence that all the values here are 1. Okay, so keep that in mind. That may not always be the case. Actually that will, yes. And then the third component is what? Negative 7 here. So negative 7, then times, and then z minus 1 equals 0 is the plane, right? Okay. And actually when we are writing this as an implicit equation, we generally put 2 zeros here, and it's saying a wavy line because I didn't tell it what to do with that. So this is the equation of the plane. And instead of solving for z, I just want to plot it like this. So what I can do is this, that I can say implicit 3, that is, make a 3-dimensional implicit plot for me. And let's go ahead and change the color of this to something else, because we had the other one blue, right? So we will take face color. Let's take green. Okay, we are all right. So we are taking that as green. And then again, I will do what? Press Control Enter. So it should just show up, to us. And then if we, come on, rotate please. And if we rotate it, you will see that the two appear to be perpendicular to each other. Or if you want to confirm, let's just go ahead and confirm numerically also. So this vector is, this plane is perpendicular to this vector, and the first one here, remember, this is perpendicular to this vector, 3, 1, negative 1, right? So if we take their dot product, what we get? Negative 27 plus 20, then these two multiply to plus 7, and that equals 0. So indeed they are perpendicular, and it looks also from the picture, right? And then if you want to print it, just click on the this live editor, say print, and it gives you an option of printing it in PDF. And let me erase all the writings here. And if I go to print, right, then it will take me to a folder. Okay, so let me just see here, naming the folder as work demo. All right, and it should print it for me, and then I can just submit this printout as my work. All right. Now we will continue to use Desmos 3D or GeoGebra 3D as our calculator, but later on for many tasks we will use the Matlab. Okay.